Welcome to our journey into the world of electricity. Today we're decoding Ohm's law, a fundamental principle that helps us understand how electrical circuits work. Whether you're a student, a hobbyist, or just curious about how things light up and power on, this guide will break down the essentials in a clear and approachable way. We'll start by exploring what Ohm's law is, why it matters, and how it applies to everyday devices. By the end, you'll see electricity in a whole new light. Let's get started by defining the basics and setting the stage for deeper exploration. Before we dive into the law itself, let's meet the person behind the name, Georg Simon Ohm. He was a German physicist and mathematician who in the 1820s conducted experiments that led to the discovery of the relationship between voltage, current, and resistance. Ohm's dedication to understanding electricity paved the way for modern electronics. His work was initially met with skepticism, but over time it became a cornerstone of electrical engineering. Knowing a bit about Ohm helps us appreciate the significance of his law and its impact on technology today. Its core, Ohm's law, is a simple equation that connects three key elements in an electrical circuit: voltage, current, and resistance. The law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points, provided the temperature remains constant. This relationship is expressed as V equals I times R, where V is voltage, I is current, and R is resistance. This formula is the foundation for understanding how electrical circuits behave and is used in countless applications, from household wiring to advanced electronics. Voltage is often described as the pressure that pushes electric charges through a conductor. Imagine water flowing through a pipe. The higher the pressure, the more water flows. Similarly, higher voltage means more electrical current can move through a circuit. Voltage is measured in volts V and is a crucial part of Ohm's law. It determines how much energy each charge carries as it moves. Understanding voltage helps us grasp why some devices need batteries of different sizes or why certain appliances require specific power sources. Electric current is the flow of electric charge through a conductor, like a wire. It's similar to the flow of water in a river. The more water, the stronger the current. In electrical terms, current is measured in amperes A and represents how many charges pass a point in the circuit each second. Current is essential for powering devices, lighting bulbs, and running motors. By understanding current, we can better appreciate how energy moves and how circuits are designed to handle different loads safely. Resistance is the property of a material that opposes the flow of electric current. Think of it as friction for electricity. Just like rough pipes slow down water, resistance slows down the flow of electrons. It's measured in ohms omega and depends on the material length and thickness of the conductor. High resistance means less current flows for a given voltage, while low resistance allows more current. Understanding resistance is key to designing circuits that work efficiently and safely. Make Ohm's law easier to remember. Many people use the Ohm's law triangle. This visual tool helps you quickly rearrange the formula to solve for voltage, current, or resistance. Cover the value you want to find, and the triangle shows you how to calculate it using the other two. For example, to find current, divide voltage by resistance. This simple trick is widely used by students and professionals alike to solve circuit problems efficiently. Let's put Ohm's law into practice. Suppose you know the current and resistance in a circuit, but you need to find the voltage. Using the formula V equals I times R, simply multiply the current in amperes by the resistance in ohms. This calculation tells you how much electrical pressure is needed to push the current through the circuit. It's a straightforward process that forms the basis for designing and troubleshooting electrical systems. If you have the voltage and resistance, you can easily find the current using Ohm's law. The formula is I equals VR, divide the voltage in volts by the resistance in ohms, and you'll get the current in amperes. This calculation is essential for ensuring that circuits are safe and that wires and components can handle the expected load. It's a practical skill for anyone working with electronics. Find the resistance in a circuit. Use the formula R equals V, I divide the voltage by the current, and you'll get the resistance in ohms. This is especially useful when testing unknown components or troubleshooting circuits. Knowing the resistance helps you select the right materials and components for safe and efficient operation. It's a fundamental step in circuit analysis and design. See Ohm's law in action with a simple example: a light bulb. Suppose you have a 12-volt battery and a bulb with a resistance of 6 ohms. Using the formula I equals VR, you divide 12 by 6 to get 2 amperes. This tells you how much current flows through the bulb. Understanding this relationship helps you choose the right bulb and battery for your needs, ensuring safe and efficient operation. Series circuit, all components are connected end to end, so the same current flows through each part. Ohm's law still applies, but the total resistance is the sum of all individual resistances. This means that as you add more components, the overall resistance increases and the current decreases for a given voltage. Understanding how Ohm's law works in series circuits is crucial for designing safe and effective electrical systems. Parallel circuits connect components side by side, so each has its own path for current. In this setup, the voltage across each branch is the same, but the total current is divided among the branches. Ohm's law helps calculate the current in each branch and the overall resistance. Parallel circuits are common in homes and electronics because they allow devices to operate independently without affecting each other. Ohm's law isn't just for textbooks, it's everywhere. From charging your phone to using kitchen appliances, this principle ensures devices get the right amount of power. Electricians use Ohm's law to design safe wiring, engineers apply it to create efficient gadgets, and even hobbyists rely on it for DIY projects. Recognizing Ohm's law in daily life helps us appreciate the science behind the technology we use every day. Resistance plays a vital role in protecting circuits and controlling the flow of electricity. Too little resistance can cause components to overheat or fail, while too much resistance can prevent devices from working properly. By carefully selecting materials and designing circuits with the right resistance, engineers ensure safety and efficiency. Understanding resistance helps us troubleshoot problems and make informed choices when building or repairing electronics. Different materials have different levels of resistance. Metals like copper and silver have low resistance, making them ideal for wires and conductors. Materials like rubber or plastic have high resistance and are used as insulators to protect us from electric shock. Understanding which materials to use is crucial in designing safe and effective electrical systems. This knowledge is applied in everything from household wiring to advanced electronics. Temperature can affect resistance in a circuit. As most conductors heat up, their resistance increases, which can impact how much current flows. This is why some devices get warm when used for a long time. Engineers must consider temperature effects when designing circuits, especially for high-power applications. Understanding this relationship helps prevent overheating and ensures reliable performance. Power in an electrical circuit is the rate at which energy is used or transferred. It's calculated using the formula P equals V times I, where P is power in watts. Ohm's law helps us find the voltage or current, which we can then use to calculate power. This is essential for choosing the right components and ensuring devices operate safely without overloading the circuit. Fuses and circuit breakers are safety devices that protect circuits from too much current. If the current exceeds a safe level, these devices interrupt the flow, preventing damage or fire. Ohm's law helps determine the maximum safe current for a circuit, guiding the selection of appropriate fuses and breakers. This ensures that our homes and devices remain safe during electrical faults. When something goes wrong in a circuit, Ohm's law is a powerful troubleshooting tool. By measuring voltage, current, and resistance, you can pinpoint where a problem might be occurring. For example, if a device isn't working, checking these values can reveal if there's a broken wire, faulty component, or incorrect connection. This methodical approach saves time and helps ensure repairs are effective. To measure resistance, voltage, and current, electricians use tools like ohmmeters and multimeters. These handy devices provide quick and accurate readings, making it easy to apply Ohm's law in real-world situations. Whether you're testing a battery, checking a wire, or diagnosing a problem, these tools are essential for anyone working with electricity. While Ohm's law is incredibly useful, it doesn't apply to every situation. Some materials, like semiconductors or superconductors, don't follow the law under certain conditions. Also, components like diodes and transistors have nonlinear relationships between voltage and current. Understanding these limitations helps us know when to use Ohm's law and when to look for other principles. Materials that don't obey Ohm's law are called non-ohmic. Their resistance changes with voltage or current, making their behavior more complex. Examples include light bulbs when hot, semiconductors, and some types of sensors. Engineers must use different equations and testing methods to work with these materials, but the basic principles of circuit analysis still apply. Superconductors are special materials that have zero resistance at very low temperatures. When current flows through a superconductor, there's no energy loss, which is very different from normal conductors. Ohm's law doesn't apply in this case, but understanding the concept helps us appreciate the unique properties of superconductors and their potential for future technology. In electronics, Ohm's law is used to design and analyze circuits for everything from radios to computers. It helps engineers select the right resistors, design power supplies, and ensure components work together safely. Mastering Ohm's law is a key step for anyone interested in building or repairing electronic devices. Modern vehicles rely on complex electrical systems, and Ohm's law is at the heart of their design. From headlights to engine sensors, understanding voltage, current, and resistance ensures that every component works reliably. Mechanics use Ohm's law to diagnose electrical problems and keep cars running smoothly. Renewable energy systems like solar panels and wind turbines depend on Ohm's law for efficient operation. Engineers use the law to design circuits that maximize power output and minimize losses. Whether it's storing energy in batteries or delivering it to homes, Ohm's law ensures that renewable energy is safe and effective. From smartphones to radios, communication devices rely on precise electrical circuits. Ohm's law helps engineers design circuits that transmit signals clearly and efficiently. By controlling voltage and current, devices can send and receive information without interference, making modern communication possible. Everyday appliances like toasters, microwaves, and washing machines use circuits designed with Ohm's law in mind. Manufacturers calculate the right voltage and resistance to ensure safe operation and energy efficiency. This principle keeps our homes running smoothly and our devices lasting longer. Learning Ohm's law can seem daunting at first, but with practice it becomes second nature. Start by memorizing the basic formula and practicing with simple examples. Use visual aids like the Ohm's law triangle and don't hesitate to use calculators or apps for complex problems. The more you apply the law, the more confident you'll become in understanding and designing circuits. In working with Ohm's law, it's easy to make mistakes like mixing up units or forgetting to convert values. Always double-check your calculations, use the correct units, and make sure your measurements are accurate. Avoiding these common errors will help you get reliable results and prevent damage to circuits or devices. Let's try a practice problem. Suppose you have a circuit with a 9-volt battery and a resistor of 3 ohms. Using Ohm's law I equals VR, you divide 9 by 3 to get 3 amperes. This simple calculation shows how easy it is to apply Ohm's law to real-world situations. Practicing with different values helps reinforce your understanding. Now let's tackle a parallel circuit. Imagine two resistors, each 4 ohms, connected to a 12-volt battery. The voltage across each resistor is 12 volts. Using Ohm's law, the current through each resistor is 3 amperes. The total current is the sum of both, so 6 amperes. Practicing with parallel circuits helps you understand how current and resistance interact in more complex setups. For a series circuit, suppose you have two resistors, 2 ohms and 3 ohms, connected to a 10-volt battery. The total resistance is 5 ohms. Using Ohm's law, the current is 2 amperes. This example shows how resistance adds up in series and how Ohm's law helps calculate the current for the entire circuit. Circuit designers use Ohm's law to ensure that every component receives the correct voltage and current. By calculating these values, they can prevent overheating, improve efficiency, and extend the lifespan of devices. Ohm's law is a foundational tool in the design process, guiding the selection of resistors, wires, and power sources. Power distribution systems, like those that deliver electricity to homes and businesses, rely on Ohm's law for safe and efficient operation. Engineers calculate the right wire sizes and transformer ratings to minimize energy loss and prevent overloads. This ensures that electricity is delivered reliably and safely to where it's needed most. Lighting systems, from household bulbs to stadium floodlights, are designed using Ohm's law. By calculating the right voltage and resistance, engineers ensure that lights operate at the correct brightness and efficiency. This principle helps prevent flickering, overheating, and premature failure, making our environments brighter and safer. Audio equipment like speakers and amplifiers rely on Ohm's law to deliver clear sound without distortion. By matching the resistance of speakers to the output of amplifiers, engineers ensure optimal performance. This principle is key to enjoying music, movies, and live events with high-quality sound. Medical devices, from heart monitors to imaging machines, use circuits designed with Ohm's law. Accurate control of voltage and current ensures patient safety and reliable operation. Engineers in the medical field rely on this principle to develop life-saving technology and maintain high standards of care. Robots, from industrial machines to home assistants, depend on precise electrical control. Ohm's law helps engineers design circuits that power motors, sensors, and processors efficiently. This ensures that robots operate smoothly, respond accurately, and perform tasks reliably in various environments. Teachers use Ohm's law to introduce students to the basics of electricity and electronics. Simple experiments with batteries, wires, and bulbs help students see the law in action. This hands-on approach makes learning engaging and builds a strong foundation for future studies in science and engineering. DIY enthusiasts use Ohm's law to build and repair gadgets, from custom lamps to homemade radios. Understanding voltage, current, and resistance helps ensure projects are safe and functional. This knowledge empowers hobbyists to experiment confidently and bring creative ideas to life. Smart devices like phones and home assistants use advanced circuits designed with Ohm's law. Engineers calculate the right values to ensure efficient charging, reliable operation, and long battery life. This principle is at the heart of the technology that powers our connected world. As technology evolves, Ohm's law remains a fundamental principle. From quantum computers to renewable energy grids, understanding the relationship between voltage, current, and resistance is essential for innovation. The law continues to guide engineers and scientists as they develop the next generation of technology. You've explored Ohm's law from its origins to its applications in everyday life and advanced technology. Remember, Ohm's law connects voltage, current, and resistance, forming the backbone of electrical engineering. Whether you're designing circuits, troubleshooting problems, or just curious about how things work, this principle is your guide. Keep practicing, stay curious, and you'll unlock the power of electricity in everything you do.